All right, today we're going to look at dividing polynomials. This is the step for a long division. Something you did last year, but we're just going to review it. Make sure you arrange your polynomial so that indices are in descending order. And that is, standard form. That means the powers, greatest to least. If you have any that are missing, any missing ones, like if it's x to the fourth your highest, but you don't have an x to the third, make sure you put a 0 in as a placeholder. Divide the first term of the dividend by the first term of the divisor. This gives you the first term of your quotient. Remember, the quotient is the answer. Multiply the divisor by the first term of the quotient, and then subtract the product. And I'm going to go through 3 examples. Subtract the product from the dividend, and then bring down the next term. The difference in the next term will be your new dividend. And remember, when you're subtracting, to be careful with your signs. That's where we make mistakes. And then you are just going to continue until you can't continue anymore, or until the dividend has a lower power than your divisor. So let's look at example 1. Our dividend is 2x to the 4th plus 7x to the 3rd. As I'm writing this, I'm making sure it's going in descending order and that I'm not missing. Minus 4x to the 2nd, that I'm not missing any powers. Minus 27x minus 18. I'm dividing that by x minus 2. So I'm looking at how many times does x go into 2x to the 4th? Well, it's going to go into 2, because 2 times, I need to have 2 times, x to the 3rd. Now I'm taking this and I'm multiplying it by this whole thing. So 2x to the 3rd times 2x is 2x to the 4th. Then 2x to the 3rd times negative 2 is a negative 4x to the 3rd. Then I'm going to subtract it. Very careful though when I subtract it. Remember, I'm subtracting that, which makes that a plus. So then I end up with those going away, which was the whole idea. And then I have 11x to the 3rd. Now this, I'll break down this next term, minus 4x squared. Now this is my new dividend, so I'm looking at how many times does x go into 11x to the 3rd? Well, it's going to go in here 11x squared. Now I multiply that by my divisor, and I get 11x to the 3rd minus 22x squared. Now subtracting this, so subtracting and plusing, those cancel, and I'm left with 18x squared. Now I have to bring down the next one. Watch. Bring down the next one. Negative 27x. I'm saying how many times does x go into that? It goes into that 18x times. That's going to be when I multiply now. That's 18x squared minus 36x. Subtracting it, so it's minus and a plus. Let's go away. And I'm up with 9x. Bring down the next one, minus 18. How many times does x go into 9x? Well, it goes in there plus 9 times. Now I'm multiplying that by my divisor. I get 9x minus 18. Subtract that, subtracting, adding, makes that 0. So none. That's my answer. That's what I get when I divide that polynomial by x minus 2. All right, let's try the next one. We have a race. So number 2, my dividend is 2x to the 5th minus 8x to the 4th plus 2x to the 3rd plus x squared. Now I don't have 0 x's and have a 0 constant. I might need that, so I'm going to put those in there as placeholders. And I'm dividing by 2x to the 3rd plus 1. So how many many times does 2x to the third go into 2x to the fifth? It's going to go in x squared. Multiply that, you get 2x to the fifth plus x squared all the way down there. Now, I can put placeholders in if I want for the rest of these, if it makes you feel better. You can do that. Some people like to, it doesn't matter either way. And I'm going to subtract these, which is subtracting that one and subtracting that one. When I do that, that cancels. Here I'm left with negative 8x to the fourth. That cancels. Here I have plus 2x to the third. And then the rest of it is zeros. I don't need to bring all of it down because I'm only going into the next. Now look at how many times does 2x, how many times does 2x to the third go into negative 8x to the fourth? Well, it's going to go in negative 4x times. Now when I multiply negative 4x times 2x to the third, it's a negative 8x to the fourth minus 4x. Oops. Minus 4x is going to be over here. So minus 0 x to the third is plus 0. Don't need to worry about x to seconds, they're gone. 0 of those. 0 of those. So I'm going to subtract this, which means I'm plussing that one as well. I'm going to do that. This goes away. 2x to the third comes down. And then plus 4x. Now, how many times does that go into that? Well, one time. Plus 1. So that is 2x to the third plus, or 0 x's plus 1. And then I'm subtracting it, subtracting that. And what am I left with? 4x minus 1. This is smaller index than my divisor, so I'm done. So that's my answer. So my answer for number 2 is x squared minus 4x plus 1 plus the remainder of 4x minus 1 over 2x to the third plus 1. That's my answer. I have a remainder. That also means that 2x to the third plus 1 could not be a factor. That's what we looked at on the hook. All right, now number 3. Last example of long division, and then we'll look at synthetic division. So we have 8x to the second plus 0 x's. We've got to put that placeholder in it. Minus 16 divided by 2x plus 1. So how many times does 2x go into 8x squared? It goes into 4x. So multiply that out. I get 8x squared plus 4x. I'm going to subtract these. Subtract. Cancels here. Negative 4x minus 16. Now again, how many times does 2x go into negative 4x? And it goes into negative 2 times. So that is negative 4x minus 2. And I'm going to subtract them, which makes that become a plus. That become a plus. And when I do that, those cancel, and I'll get the negative 14. And that's remainder, because I can't divide into that one. My answer is 4x minus 2 minus 14 over 2x plus 1. Also not a factor. Now, synthetic division we can use as long as our denominator is linear, which in both of these examples it is. You also want to make sure that you have it in the form of x minus c, meaning that if there was a number in front of x, you would have to divide the constant by that. So that you can do synthetic division. Very similar to long division, in that we have to make sure our dividend is in order by the powers and that we're not missing anything. But we just write down the coefficients. 2, 7, negative 4, negative 20, negative 18. If we're missing something, we'd write 0. And then we're dividing that by 2, not negative 2, because remember the form says minus. We're just dividing it by 2. So we bring this first one down. Multiply. 2 times 2 is 4. Add those, that's 11. Multiply. 2 times 11 is 22. Add those, and we get 18. Multiply. 2 times 18 is 36. Add those, and we get 9. Then multiply. 2 times 9 is 18. Add those, and we get 0, which means we don't have a remainder. This last slot would be a remainder if we had it. So that means it went into that evenly. And our answer, when we're dividing it, is 2x. Now it's 1 less. This is x to the third. X to the third. Plus 11x to the second. Plus 18x plus 9. In fact, if you look at the first problem within long division, it's the same problem. We got the same answer. Now looking at number 2. Start with our dividend, 5, 0, because there's no x squared, 6 and 8. And we're dividing it by negative 2 here, because that was a plus. That means it's minus a negative, which means we're dividing by the negative. We bring this down, that's 5. Negative 2 times 5 is a negative 10. Add those, we get negative 10. Negative 2 times a negative 10 is a negative 20. Add those, and positive 20, not bad. Negative times negative is 26. And then negative 2 times 26 is a negative 52. We add those, we get a negative 44. So this one does have, oops, look that's good, does have a remainder. So the answer for this one would be 5x squared, because remember it's 1 less than what we started with, minus 10x plus 26 minus 44 over x plus 2. So that's our synthetic division. So what's this going to help us do? It helps us know if something is a factor. All right, now we're going to look at the remainder theorem. If a polynomial p of x is divided by x minus a, then the remainder is r, which is equal to the p of a. So what does that mean? Well, let's do this one. Let's evaluate this function at negative 1. 3 times a negative 4 cubed plus 4 times a negative 4 squared minus 5 times a negative 4 plus 6. Put that on our calculator. What is the f of a negative 4? F of a negative 4 is negative 1/5. So I'm going to test this theory. This says if we're dividing by that same thing, that we would get the same remainder. So let's look at that. We'll do synthetic division, 3, 4, negative 5, and 3. And we're dividing it by negative 1. Bring this 3 down. Negative 12. Add those, that's a negative 8. Positive 32. Add those, and we get 27. Negative 4 times 27 is negative 108. And those we get negative 105. Look at that. The remainder is the same thing as if we evaluated that function at negative. So once you finish the next problem, you can try this one on your own. All right, the next problem, factor theorem. It says if the p of a is equal to 0, then we know that x minus a is a factor. X minus a is a factor. Conversely, if x minus a is a factor, then we know that the p of a is 0. So this one says use the factor theorem to determine if x to the negative 2 is a factor of f of x. If so, factor it completely and then explain. So a couple ways you could do this. You could plug in 2 and see if it works. See if it gives you a 0. So 2 to the third minus 7 times 2 plus 6, that's 8, minus 14 plus 6, that's a negative 6 plus 6. That equals 0. So yeah, it would be a factor. You can also test it with synthetic division if you don't trust that. 1, 0, negative 7, and 6. Dividing it by 2. Bring down our 1. That's 2. 4. Negative 6. And before we get that, 0. So we know that x minus 2 is a factor. Now I would suggest using the synthetic division here, because this right here gives you what's left. X squared plus 2x minus 3, which then we can factor this using what we learned in Algebra 1 and Algebra 2, looking for factors of negative 3 that add to give me 2. So that's going to be x minus 3. And then those are our factors. From there, we could determine our solutions. Oops, did that one. Sorry, I should have x plus. Double check that sign. I knew something going. And x minus 1. That's a plus.